My name is Ayn Joshi. This is my paper presentation on the topic how Amazon Web Services uses formal methods. The authors are Chris Nicom, Tim Rath, Fan Zhang, Bogdan Montiel, Mark Burker, and Michael Diodev. Now let's continue. Introduction. What is formal method? Formal method is a particular kind of mathematically based techniques for the specification, development, and verification of software system. It requires performing appropriate mathematical analysis that can contribute to the reliability and robustness of a design. Now, according to this paper, the formal methods finds bugs in system designs that cannot be found through any other techniques we know of. Formal methods are surprisingly feasible for mainstream software development and give good return on investments. And at Amazon, formal methods are routinely applied to the design of complex real-world software, including public cloud services. Since 2011, Amazon Web Services (AWS) have used formal specification and model checking to help solve difficult design problems in critical systems. Amazon Web Services attempts to provide simpler services for the customer, and external simplicity is built on a hidden layer of complex distributed system in order to achieve high availability, scalability, and low cost. For example, AWS launched S3 Simple Storage Services. S3 is just one of many services that store and processes data. To safeguard that data, the core of each service relies on fault-tolerant distributed algorithm for replication, consistency, concurrency, control, auto-scaling, load balancing, and other coordination tasks. After deep design review, testing the code is inadequate as a method for finding subtle error in design, so we look for a better approach. Looking for precise design. In order to find subtle bugs in the system design, it is necessary to have a precise description of that design. So to avoid plausible errors, specific tools can be applied to check for errors in the design even while it is being written. So as the design are too complex, a highly expressive language is required above the level of code with precise semantics. These properties that were required was found in TLA+, a formal specification language based on simple discrete math or basic set theory and predicates. TLA Plus is intended to make an easy approach to so a system design correctly implements the desired correctness properties through either conventional mathematical reasoning or tools like the TLC model checker. At first, the syntax and idioms of TLA Plus are somewhat unfamiliar to programmers, but TLA Plus is accompanied by a secondary language called Pluscal that is somewhat similar to C-style programming. Pluscal is intended to be direct replacement for pseudocode, and Pluscal user too have to be familiar with TLA Plus in order to write rich expression, and because it is often helpful to read the TLA Plus translation to understand that precise semantics of a piece of a code. The side benefits. TLA Plus has been helping us shift to a better way of designing system. It begins precisely with defining correctness properties, that is safety and liveness, addition of new features, redesign of components to handle massive increase in scale, and performance enhancement are done with no downtime. There are major benefits of having precise testable model of the core system. Even the deep changes are safe or unsafe without doing any harm. What formal specification is not good for? Bugs and operator errors are major class problem in large distributed system, which results in performance degradation and departure from system's logical intent. For example, when a momentary slowdown in a server causes timeouts to be breached on clients, causing the clients to retry request, thus adding load to the server and further slowdown. First steps to formal methods. It started with the author's dissatisfaction with the quality of several distributed systems he had designed and reviewed, and with the development process and tools that has been used to construct those systems. The systems were considered successful, yet bugs and operational problems persisted. To mitigate the problem, the system used well-proven method to detect symptoms of bugs and mechanism to attempt to minimize the impact when bugs are triggered. A language called Alloy was used to find serious bugs in the membership protocol of the distributed system. However, it was found that Alloy is not expressive enough for many use cases at Amazon Web Services. So the author stumbled on the language TLA plus. The widely used algorithm in TLA plus gave them some confidence that TLA plus would work for a real world system. The authors evaluated both TLA plus and Alloy by writing a specification of the same non-trivial concurrent algorithm. Both Alloy and TLA plus were able to handle the problems, but the comparison revealed that TLA plus is much more expressive than Alloy. The first big success at Amazon. In 2012, Amazon launched DynamoDB, a scalable high-performance NoSQL data store that replicates customer data across multiple data centers while promising strong consistency. But TLA Plus has the highest level of confidence than the DynamoDB. As a result, author chose TLA Plus. The use of TLA Plus continued to verify changes to the design for both optimization and new features, persuading more engineers. With success of both DynamoDB and TLA Plus, it was exposed to the broader engineering community as Amazon. Executive management actively encourages teams to write TLA Plus specifications for new features and other significant data changes. The advantages of formal methods. The get right design. Formal methods help engineers get the design right, which is necessary for step towards getting the code right to gain better understanding. Formal methods help engineers gain a better understanding of the design and write better code. Formal methods can help engineers write better self-diagnosing code in the form of assertion. These are the advantages of formal methods. Alternatives to TLA plus. There are many formal specification methods. Several methods were evaluated taking account of the requirements that are important for the formal methods to be successful in industrial segment. TLA plus met all those requirements. Further evaluation methods were stopped at the present time as the goal was always practical engineering rather than an exhaustive survey. The search has been halted as necessary requirements are met by TLA plus. If further requirement arises or any discrepancies are found in TLA plus, the search for the alternative begins. The related work. Relatively little published literature on using high-level formal specification for verifying the design of complex distributed system are found. The Farsight Project 6 is complex but somewhat different from the types of systems described here and apparently never launched commercially. These are the related works done. In conclusion, formal methods are a big success at Amazon Web Services, helping to prevent subtle but serious bugs from reaching production, bugs that would not have been found through any other techniques. It has helped devise aggressive optimization to complex algorithms without sacrificing quality. And using TLA Plus will improve both time to market and quality of our system. Thank you very much.